This is a bit of a sneaky McBeaky transformations question. So describe fully the transformation that maps triangle A onto B. I think what I do when I look at this sort of question is think, you know, I've got my four transformations in my head and I try and like narrow down what it could be. So for example, it's not a translation because it's clearly changed orientation. It's not an enlargement because it stayed the same size. Um, it's in this case it's not a reflection because if I rotate it, it's going to not be facing the right way. So it has to be a reflection. Now they're unlikely to give me a really weird line of reflection, I suppose. I mean, should I really thinking of it like that, as in I'm just trying to do an exam? But I think that's in my head a little bit. It's not going to be horizontal or vertical, so it's probably going to be one of the classic kind of lines that you get, either y equals x or y equals minus x. And if I put in y, it's not going to be y equals minus x. If I put that in, then I can kind of just try a point. I can see I go 2.5 diagonals, and then I go 2.5 diagonals, so that one works. Here I'm going 1, 2, 3, 3.5 diagonals, and I can see that that is going to work. So describe fully the single transformation, reflection in y equals x. You need to be able to identify and use the lines y equals x and y equals minus x really quickly. Triangle A can also be mapped onto B using a combination of two transformations like it. A transformation T followed by a reflection line x equals 0. Describe fully transformation T. Well, I think the thing to do here is do the reflection in the line x equals 0 of the final one. So we're actually gonna, this is, oh wait, x equals 0 is here. So I'm going to reflect it in this line. It's going to be here, 1, 2, 3, 1, 2, 3, and then this is going to end up over here. Okay, so basically I want to do something with A to take me to here, and that's my transformation T. And then after that, I reflect it in x equals 0, and that takes me to B. So I've done this, I've gone backwards. I've got my final answer, and then I've reflected it back into x equals 0, because now I can just focus on my transformation T. Now again, what's going on? It's not a translation. It doesn't look like a reflection this time. It's not an enlargement, so I'm thinking it's going to be rotation. And the key thing to do with this is get your tracing paper, go over your shape with a pencil, and then essentially you have to kind of try different points that might work. But there is a bit of there's two pieces of advice. First of all, always try the origin first because a lot of the time that will work. Okay, that's just an exam technique kind of one. But the other one is that like the points are going to be the same distance away. So this is not possibly going to be the center of rotation because the bottom corner is only one away diagonally, whereas it's loads away diagonally over there. So it's got to be kind of the same distance away, which is why if you actually look at the origin, that's looking good because here I go along 3 and up 1, and here I go down 3 and along 1, so I can see they are the same distance away. And if I take it and I rotate it, this is me rotating about the origin, I'm rotating it anti-clockwise, I see that it does actually match up to where I want it to, so that's good. To describe fully transformation T, I'd get some credit for sort of having put my triangle in, and then I would say that it is a rotation about, you could say about the origin or about 0, 0, anti-clockwise. By 90 degrees. I think that's a hard transformations question, but Hopefully you're happy with it, and that is the answer.